Okay guys, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, I would like to discuss about the last subtopic in chapter 5, okay, system of ODE. Okay, in a real life problem, most of the problem, okay, involve with system of ODE rather than single ODE. So what is a system of ODE? System of ODE, that means you will have more than one differential equation. For example, this is the first differential equation, second differential equation, until n differential equation. And all the differential equation requires n initial conditions at the starting values of x. So in this subtopic, okay, we just cover for n equal to 2 only. That means we just have two differential equation. So this is the example. This is the first differential equation and this is the second differential equation. Since we have two differential equation, that means we will have three variables, okay, x, y, and z, where y and z will become our dependent variable, while x will become our independent variable. Given to us also, okay, the domain, or we call it as interval here with the initial condition. Since we have two differential equations, so we will have two initial condition. The first one for y naught and the second one for z naught. Now, let's see the different, okay, formula between single and system of Euler equation. Okay, for single first, okay, we have two equations. The first equation is xi plus 1 is equal to xi plus h. And the second equation is how to calculate y. So we will have yi plus 1 is equal to yi plus f xi yi multiplied with h with initial condition y x naught is equal to y naught. So this is formula for Euler for single. So now we go to the system. Since system we have two differential equation with three variable. So we will have three equation. So the first equation, xi plus 1 is equal to xi plus h. Second equation, okay, for calculate y, so we have yi plus 1 is equal to yi plus f1, so xi, yi, zi multiplied with h. And the third equation is how to calculate our z. So we have zi plus 1 is equal to zi plus f2 xi, yi, zi multiplied with h. And we also will have two initial condition. Y x naught is equal to y naught, and another one, z x naught is equal to z naught. Now let's try one example. Use Euler method to solve the following system of ODE. Okay, for interval 0 until 1 with a step size h equal to 0.5. So we have two differential equation here. So this is equation number 1 will be our f1 and this is equation number 2 will be our f2. Okay, and this is our initial condition. Y0 is equal to 2 and Z0 is equal to 4. Okay, so this is our interval. Start from 0 until 1 and our step size is equal to 0.5. Okay, so now let's sketch our timeline. So this is our timeline. Okay, x start from 0 until 1. So x naught is equal to 0. And the increment h is equal to 0.5. So we have x1 is equal to 0.5 and x2 is equal to 1. Okay, now substitute our initial condition. So we have here when x is equal to 0, y is equal to 2. So x0, so y0 is equal to 2. And we are going to find value for y1 and value for y2. The second condition, when x0, z is equal to 4. So z0 is equal to 4. Okay, and we need to find the value for z1 and value for z2. Now let's start with the solution. Okay, first of all, formula Euler for system. Xi plus 1 is equal to xi plus h. Yi plus 1 is equal to yi plus f1 xi yi zi multiplied with h. And for zi plus 1 is equal to zi plus f2 xi yi zi multiplied with h. And our f1 is equal to minus 2yi plus 4 exponent minus xi, and f2 is equal to minus yi zi squared divided by 3. And our initial condition that given to us, y0 is equal to 2 and z0 is equal to. Okay, so when I equal to 0, so by using the first equation, we have x1 is equal to x0 plus h. That means 0 plus 0.5 equal to 0.5. And then y1 is equal to y0 plus f1 x0 y0 z0 multiplied with h. So what is our y0? 2. Our f1 x0 is equal to 0, y0 2, z0 4 multiplied with 0.5. Then just substitute 0, 2 or 4 into our f1 here. So you will have for f1 0 multiplied with 0.5, so you will have 2. Okay, so this is value for y1. And then how to calculate our z? So by using the third formula, so z1 is equal to z0 plus f2 x0 y0 z0 multiplied with h. So z0 4, f2 x0 0, y0 2, z0 4 multiplied with 0.5. So how to calculate f2? You just need to substitute 0, 2 or 4 into our equation f2 here. So you will have 4 plus minus 32 divided by 3 times with 0.5. So value for z1 is equal to minus 1.3333. We are not finished yet. Okay, from the first iteration when I equal to 0, so we already have value for x1 equal to 0.5, y1 is equal to 2, and z1 is equal to minus 1.3333. So now let's continue to calculate value for x2, y2 and also z2. So here I is equal to 1. Okay, when I equal to 1, so I will have x2 is equal to x1 plus h. That means 0.5 plus 0.5 is equal to 2. And then y2 is equal to y1 plus f1 x1 y1 z1 multiplied with h. So y1 is equal to 2. f1 x1 0.5 y1 2, z1 minus 1.3333, and our h is 0.5. So how to calculate the value for f1? You just substitute into our equation f1. So we will have y2 is equal to 1.2131. Then continue to calculate our z2. So z2 is equal to z1 plus f2 x1 y1 z1 multiplied with h, and substitute the value. Z1 minus 1.3333, f2 x1 is equal to 0.5, y1 2, z1 minus 1.3333, and h is equal to 0.5. Then how to calculate f2? So just substitute into equation f2. So we will have z2 is equal to minus 1.9259. So actually So this is the value that we want to find. Okay, so if we refer to our timeline again, so we have value for x0, x1 and x2, and we already calculate for value for y0, y1 and also y2, and we also have value for z0, z1 and z2. Okay, now let's try another example. Example 2. So this is exercise from our module. So solve system. So we have two differential equations. So this is equation 1 will be our F1. And this is equation number 2 will be our F2. Okay, so our equation in terms of x, y, and t. And this is our initial condition given to us. And we have some information here. So A is equal to 3, B is equal to 2.4, C is equal to 1.3, and R equal to 8.7. And our step size is delta T is equal to 2. And you need to find X when T is equal to 2. And Y when T is equal to 2. Okay, by using Euler method. Okay. So let's substitute all the information that we have. So F1 is equal to 3x minus 2.4xy. And then F2 we have minus 8.7y plus 1.3xy. Okay, so and then let's sketch our timeline. So this is our timeline. So we start with T0 is equal to 0, y0 here. Okay, initial condition. And then our step size 2. So T1 is equal to 2. And the question asks you to find x when t equal to 2 and y when t is equal to 2. So this question is very simple because you just need to find, okay, x1 only. You just need to find y1 only. Okay, so x0 is equal to 4 and y0 is equal to 2. So we are going to find x1 and y1. So let's start with the calculation. So here is the formula for Euler for system. So we have Ti plus 1 is equal to Ti plus h. And then we have xi plus 1 is equal to xi plus f1 ti xi yi multiply with h, and another equation we have for yi plus 1 is equal to yi plus f2 ti xi yi multiply with h. Okay, and our f1 and also f2, f1 is equal to 3xi minus 2.4xi yi, while our f2 is equal to minus 8.7 yi plus 1.3xi yi. Okay, so we just need one iteration only because we just need to find x1 and y1 actually. So we start with I equal to 0. So we will have T1 is equal to T0 plus H. That means T0 is equal to 0 plus our step size is equal to 2. So we have 2. And then for x, so when I equal to 0, so we will have x1 is equal to x0 plus f1. Okay, T0, x0, y0 multiply with h. So what is our x0? x0 is equal to 4 plus f1. T0 is equal to 0, x0 is equal to 4, y0 is equal to 2, and h is equal to 2. H is equal to 2. So calculate your f. So just substitute this value into our f1 here. So we will have 4 plus minus 26.4. So substitute, okay, just use calculator, you will have minus 10.4. So this is value for x1. Okay, how about y? So by using the third formula, so y I equals to 0, that means we will have y1 is equal to y0 plus f2. Okay, t0, x0, y0 multiplied with h. So just substitute all the value we have. So y0 is equal to 2. Okay, F2, T0 is equal to 0, X0 is equal to 4, Y0 is equal to 2, and H is equal to 2. Okay, so you just substitute everything, and how to calculate F2, just substitute the value into our equation here, F2. So we will have 2 plus, okay, minus 14. Okay, so you will have minus 12. So this is our final answer here. Okay.